Okay, so this lesson video is going to be on something that we ran into today with Pythagorean theorem, and that was square roots. So we had to do square roots in order to get the final answer when using Pythagorean theorem. And sometimes those answers, well, they don't work out real well. And you need to know something about perfect squares and how to simplify radicals in order to be able to work with that. So this lesson is on simplest radical form, and you're going to need to use your own notebook paper. So if you don't have a sheet of notebook paper right now, pause the video, go grab a sheet of paper and come on back. But what we're doing here is simplest radical form. And you need to know how to do this because it's going to keep popping back up during geometry this year. We're going to show it to you right now, and then we're going to see it again later and see it again later, and eventually you're going to be an expert. All right, so what do we mean by a radical? A radical is this symbol. You've seen that before. Mostly you've seen it for square roots, but it could also be used for cube roots, fourth roots, fifth roots, etc. Right now, all we're worried about are square roots because that's what's coming up with Pythagorean theorem. All right, so what I mean by doing a square root would be, for example, the square root of 100. So what is the square root of 100? What number times itself equals 100? And that is 10. So it's really helpful if you know the perfect squares for what we're going to be doing. So what I'm going to do is do a little cheat sheet or a little reference box over on the right-hand side of my paper. We're going to keep referring back to it. And we're going to list our perfect squares. All right. And you did learn how to write things in simplest radical form in algebra. It's just one of those things that people need reminders of quite frequently. All right, so our perfect squares, here we go. 1 squared is 1 times 1, which is 1. 2 squared is 4. 3 squared, 3 times 3 is 9. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared, 49, 8 squared, 64, 9 squared, 81, and I'm going to stop at 10 squared, 100, although we could go on forever, and it would be helpful that you know at least up to 13 squared or 14 squared, but that's okay. We'll just stop right there. And the other thing that we want to remember is the square root of 4 then, the square root of 4 takes us back to 2. And the square root of 9 takes us back to 3. And the square root of 16 takes us back to 4. Now I showed you that for a reason. The square root of 4 is pretty. It just gives you this nice, beautiful 2. And the square root of 9 gives you 3. That's great. But what about the square root of 5, 6, 7, and 8 that are right there in the middle? Well, they must be in the middle of 2 and 3, which means that you're into decimals. And in fact, when you do the square root of a non-perfect square, you get an irrational number, a never-ending non-repeating decimal. For example, think about the square root of 6. That's almost smack dab between 4 and 9, getting pretty close to being in the middle of that. So our square root of 6 is going to be between 2 and 3. So let me bring up my calculator here. And we'll put in 6 and square root. And look, it's between 2 and 3, almost smack dab in between 2 and 3, right? And that was kind of what we expected. Do you see this decimal? Oh my gosh, this decimal actually goes on into infinity, just like pi. It's a never-ending, non-repeating decimal. That's an irrational number. We'll bring our calculator back here in a minute. All right, so how do we do simplest radical form? Well, I'm going to use the square root of 20 as my first example. So go ahead and write that down. You should be writing what I'm writing. Get a little closer here. All right. So in order to do this, I need to take 20 and find a multiplication fact that equals 20 that includes one of these perfect squares. So go down this list. Do you see a number in the list that when multiplied by something else would equal 20? Look at that right there. 4 times 5 would be 20. So I'm going to come over here and draw my radical sign, and I'm going to put 4 times 5 instead of 20, right? Now 4 being a perfect square, we can go ahead and take the square root of 4 and go, boop, pop it out, it's a 2. The square root of 4 is 2. Notice now my 2 is outside my radical sign and the 5 is inside my radical sign. This is really important. You got to keep those straight. The 2 is outside, the 5 is inside. And we read this as 2 radical 5. It is equal to radical 20, or the square root of 20. And I'm going to prove that to you on my calculator again. Okay, so the square root of 20, as you can see, is this. Now I need you to look at that because I need you to try to remember if you recognize it later. 4.472135. Okay, you kind of got that in your head, right? Clear. Now look at 2 radical 5. This means 2 times whatever the square root of 5 is. So I'm going to do the square root of 5 and then multiply that by 2. All right, does that look like what we had when we did the square root of 20? Yes, it does. There it is. So these two are exactly equal to each other. It's like simplifying a fraction. It's like as if you started with 3/6 and you simplified it to 1/2. They mean exactly the same amount. They just look different. One is simpler than the other. That's the simplest form. And I know this is the simplest because look at the number 5 underneath. There's nothing in this list that I could make a multiplication fact of one of these times another number to make 5. Now I know 1 would. 1 times 5 does equal 5. But the square root of 1 is 1 and it has no impact on any of this. It still stays exactly the same. So for our purposes, having this here is not helpful. We'll just ignore it. We don't even need that one there. All right, let's do another example. We'll do the square root of 75. All right, so to simplify this, you need to go down through this list and find any number in that list that when multiplied by something else will equal 75. Do you see it? Right there. 25. 25 times 3 equals 75. Okay, so then we go to the square root of 25 and go, whoop, that's 5. There you go. The 5 is on the outside, the 3 is on the inside. So we say 5 radical 3. I've watched lots of students over the years get this mixed up. They'll look at this and go, oh yeah, I know I have a 5 and I know I have a 3, and they'll write it as 3 radical 5. Well, that's not true, and that's backwards. So always tell yourself, this one's outside, this one's inside, outside, inside. Keep them straight. All right, our next example is the square root of 300. Okay, go down through that list. Do you see a perfect square that will work? There it is, right there. So we're going to rewrite this as 100 times 3. The square root of 100 is 10. 10 is on the outside, 3 is on the inside. You're done. 10 radical 3. Okay. Let's do the square root of 27. All right, now, if you feel like you've gotten pretty good at this, pause the video, do this one on your own, and then start it back up again and check and see how you did. I think you can do this. All right, here we go. Find a number in this list that when multiplied by something else will give you 27. That would be 9 right there. So we're going to do the square root of 9 times 3. 9 is the perfect square. The square root of 9 is 3. And we rewrite it as outside, inside. 3 radical 3. All right. So I'm going to do one. It's kind of a challenge one. Well, hold on. Let's see. All right. Let's see what you can do with this one. The square root of 15. All right. Look down through that list. You're looking for something when multiplied by something else gives you 15. Well, it has to be less than this, 16, right? So it would have to be 4 or 9. Can you multiply those by something to make 15? No, you can't, which means the square root of 15 is already simplest form. There's nothing you can do to make that any simpler. And that happens sometimes. There you go. All right, here is the challenge one. What about the square root of 800? When these numbers get awfully big, we have to be super careful that we have simplified them as far as possible. So first we had one very similar to this right here. So I know that 100 is going to be a perfect square that'll work. So we'll do 100 times 8. Okay, and ooh, pop that 10 out. And we get 10 radical 8. Boy, that looks a lot simpler than that. That's great. But look at this 8. Be careful. If the number you started with was awfully big, you need to reevaluate there at the end to make sure that that can't be simplified any farther. Can it? Look at your list of perfect squares. Do you see that 4 sitting there? All right, we can simplify it again. So I'm going to rewrite this as 10 times the square root of 4 times 2. 8 is 4 times 2. The square root of 4 is 2. And remember, all of this was being multiplied together. This is 10 times the square root of 8. This is 10 times whatever the square root of 8 is, or 10 times 2 times the square root of 2. So 10 times 2 equals 20. And that 2 here is still under the radical sign. So this is 20 radical 2. So see, that one took a couple steps because we didn't pick the biggest perfect square that would have worked here. The biggest perfect square that would have worked here was 400. We could have done the square root of 400 times 2. It would have taken us straight to this. All right, so beware of those. All right, so the next thing you're going to do is write down 5 practice problems. So you're going to copy them from what I write here, and you're going to try them yourself, bring them to class tomorrow, and we'll see how you did. All right, so you're going to do the square root of 8. Number 2 is going to be the square root of 12. Number 3 is the square root of 50. Number 4 is the square root of 45. And number 5 is the square root of 18. So I didn't give you any really big, humongous numbers or anything. I do want you to try these. Use the samples from earlier in the video. Go back and look at your notes. This piece of paper is going to get folded and taped into a section of your Geometry Nation book. So do not lose this. You're going to be able to refer back to it later this year every time we hit simplest radical form. All right, try your best. I hope to see a lot of great answers tomorrow when we go over it in class. Talk to you later. Bye-bye.